And so the last one I want to show you is the App-to-Infra scenario. So for that one, I'm going to take you back to the map. I'm going to take you to the map and let me remove this one. I think we have a filter in here. There we go. So I really want to go into the infrastructure layer. And as we said, our application is, let me remove this. And as we said, our application is running in Kubernetes, which in turn is running in AWS. So I have the various types in here. Um, and what I want to do, if I want to expand, so if I open my Kubernetes to take a look at my Kubernetes, I see that I have two working nodes. But I can expand my scope, if you will, go to maybe the enterprise level, and now I see more components, right? Now I can see, for instance, in my Kubernetes types, I can see my entire Kubernetes cluster, right? In this case, in our case, Kubernetes is composed of two working nodes and a master, right? So I can see my master node, right, and the two working nodes that my that composes my Kubernetes cluster. If I expand on one of my working nodes, I can see that the working node is actually running on this particular EC2 instance, right, with the IP number, so on and so forth. And I've expanded that one. I can see the various projects now, right, that are running within that working node or within that host, right? Now, I may have obviously projects. Uh, Really, it's a namespace or scope, where it defines where various teams deploy their own applications. Excuse me. In this case, I see three projects. One is Kube System. This is the Kubernetes project itself, where they have their own pods. APM monitoring. These are the things that we deployed um, in order to monitor, to track the Kubernetes cluster. And the ticket exchange project. This is where we actually deployed our ticket exchange, and we can see that the web portal is a pod deployed under this project. Okay, we can see the dependency. We can see that this pod itself, right, it's actually calling to another, right. It's making a call into this other working node. Excuse me, into this other working node. And if I expand that working node, right, we're probably going to expect to see that indeed this actually let me see if I can highlight this. I don't want this. I can see that this actually web portal, right? The reason why it's got a dependency or was calling into the other working node is because we see that the authentication server, which is this guy, is actually running in that working node. All right. So let me close this. Uh, So the one last thing I want to show, if you guys are running Kubernetes, I just want to make sure that you're aware that not only do we monitor, obviously, the applications and pod running within the applications that we're monitoring, but we also can monitor the uh, backplane of Kubernetes, right? If we open the masters, for instance, the master node, I can see a couple of critical pods that obviously I'm very interested in monitoring their performance, like the ETC server, the DNS controller, uh, the API server, right, and so on and so forth. All right. So with that now, let's go ahead and let's select this particular working node. And now what I see on my right, I see these tabs, okay? And this is where the correlation now takes place. What this is telling me is that, look, within this uh, container, we have EC2 and WS, right? This is running on this particular host. Okay, this particular host, right, is actually has all these various projects running in it, and if I expand a project, I can see the pods of of those projects, right? So now this helps me understand the performance, not just of my pod, of my application, my pods, but also correlate that to the performance of my host and what's going on AWS on my public cloud as well. So for instance, let's select, we go to the tab, And all this is within that context. So if I look at my EC2, this is the EC2 metrics that I'm getting from CloudWatch. I can get all the related metrics from there, as well as, very importantly, right, all the tags, names that I might have defined in AWS. The reason why this is important and critical to capture is because I may have, use certain tag names for certain EC2s or whatever. Um, that I may want to group in order for it to make more sense, right? I might have, called them. Let's say I have a bunch of EC2s out there deployed that are hosting my databases, my various databases. So I may want to tag those EC2s as databases, and then when because I'm able to import that automatically from AWS into Interscope. Um, I can group those, database servers into a single component, into a single group, right? That's reducing the complexity of having, an explosion of nodes on my dashboard. Um, Similarly, this is from SO2. I can also look, if I look at inside my EC2, I see that there is an actual host, right? And so the host itself will also monitor, we're able to monitor the CPU of that host, right? CPU metrics, memory metrics, network metrics, etc. And again, the same concept, a lot of metrics and the same concept as attributes, right? I may have, for instance, like this one, I may have a label, an attribute of the operating system of that particular host. That again, if I had various flavors of, say I had Linux and Windows, I could easily then use this attribute, right, this label, and group them, group all the different servers by operating system types. Okay. Um, and lastly, as we said, uh, we're inside AW2, we're inside AWS, we're running on this particular host, and we're running Kubernetes. So if I look at Kubernetes now, I can see the pods that are running within this working node, right? And that's because I have selected at this level. I could obviously, narrow down my selection and just select a particular pod, and I'll see that now, the metrics that I'm collecting is just for this particular pod, right? Or I can look at an aggregation and take a look at the various, a summary of all the pods together. Okay. Um, Again, just like before, we're capturing all the labels that you guys use for your Kubernetes, which again they can be used, leveraged to create better, more meaningful perspectives, right? More meaningful dashboards. The last thing I want to show is this idea of correlating between app and infra, so that uh, if I'm looking at a host, right, if I'm looking at at a working node like I am in this case, I can easily see the various applications that are running on the working node, right? All the various pods that are running on that working node. So that, for instance, if let's say this working node which is running on this host, and the host happen to have high CPU, or maybe it's running out of memory, I can look at, I can come into this map and be able to see which applications may be affected, right, by the high CPU or the lack of memory on that working node, right? Um, and that's very powerful, right? Similarly, I can go the other way around. I can select a particular application, right? Um, and be able to navigate backward and be able to see, and be able to see uh, the actual pod, right? That my application is being hosted, the actually host where my application is running, and be able to look at the performance of that host and see if maybe my application is slow because I don't know, there's no CPU, or there's a network problem or whatever it may be. Okay, so this is the power of App-to-Infra correlation that APM provides. And with that, that concludes use case number 3.